Okay, here's where we left off in the last video. Um, and the question here, we talked about uh, the fact that we need to take into account when we're trying to evaluate someone's performance, we need to take into account what the rest of the class did, right? What the rest of the distribution looks like, which is given by our measure of central tendency here. So you scored at 85. The average for the rest of the class is 75, right? And so we're going to do a deviation score that tells you how your performance compares to the average. So if this is a positive number, in this case, of course it is, we're above the mean, okay? If it's a negative number, it means that we're below the mean. And if it's 0, that means that we're at the mean. We're scoring average, okay? And I covered a number of examples that I hope really brought home the point that we need that information to make an evaluation of performance. And we're going to talk about evaluating or assessing numbers. So, what do they mean, okay? And then I ended the last video by asking, well, does it matter what the standard deviation is for the distribution of other scores? So this tells us where the other scores are located, the central tendency. And for a normal curve, this is going to be an accurate sort of depiction or indication of where the center is. We're going to look at the deviation, but does it matter what the standard deviation is? And the answer is yes, it does matter, because, well, in order to answer the question, we have to ask ourselves or remind ourselves again, what does standard deviation mean? And of course, standard deviation also we can also refer to it as the average deviation. And this tells us, on average, how much do scores deviate from the mean? Okay, on average, how much do scores deviate from the mean? And it's a measure of variability or a measure of spread outness. Okay, and so let's think about what this means. So this means that the average for the exam was a 75, and then on average, people deviated by about 10 points, okay? Standard deviation, okay? For exam 2, on average, people scored 75, right? That's the mean. And the amount on average that they vary, that they deviate from the mean, is 5. And then, of course, here the average is 75. This average amount that scores deviate from 75 is 3. Okay? And I hope that you can sort of imagine what this looks like in a graphic representation. So I'm going to, for the sake of simplicity and to try to drive home the point, I'm going to consider exam 1 and exam 2 just to give us some room here, because I want to make a graph of what these look like. Okay, the mean is 75 for each of these, and then one of the distributions has a standard deviation of 10, the other one has a standard deviation of 3. So let's draw a graphic representation of that to see if this helps us with our understanding that knowing the standard deviation, in addition to knowing the average, will help us in understanding how well or how poorly this person performed. Okay, so let's take a look. So here's what it would look like in graphic form, right? So for both exam 1 and exam 3, the mean is 75. And I'm going to assume that we have a normal distribution. And so let's do this. Let's make this represent exam 1. Okay, so has a mean of 75 and a standard deviation of 10. Relative to this curve, then, another distribution that's normally distributed that has a mean of 75, but now a standard deviation of 3, what would that look like? Well, it's going to be less variable. It's going to be less spread out. That is, a distribution with a standard deviation of 3 is less spread out than a distribution with a standard deviation of 10. So let's do a graphic representation, and maybe okay, so this is going to be exam 3. So this has, again, this has a mean of 75, but the solid line represents a standard deviation of 10, and the dotted line represents a standard deviation of 3. Okay, so that's what we have. This would be a graphical representation of those two distributions. Now, your score for exam 1 and exam 2 is 85. So you're 10 points above the mean, and let's just say here's our 10. This is 10 points above the mean, right? So let's say this is an x value of 85. Okay. So we're going to assess how well you did. Now, for both exams, you're 10 points above the mean. Good job, okay? You're above average. But does that 10 points mean something different for exam 1 as exam 2? And the answer is yes, it does mean something different. So if we look at, let me ask the question in a different way here. For exam 1 or exam 3, which one would you rather be in? If you had a choice, which distribution would you rather be in if your score is 85? So if you're sitting here, right, or if we talked about these as two different classes or something like that, which of the exams did you perform better in? Now, we're not just going to pay attention to how far above the mean you are. You're 10 points above the mean in each. Let me ask the question a little bit differently. In which class did more people do better than you? Okay, in which class did more people do better than you? Well, remember, here's our score of 85. So this tells us for exam 1, this many people did better than you. Remember, the area underneath the curve represents the blocks that are underneath the curve. So not as many people, so this many people did better than you. You certainly did better than the majority of the class. You're above average, right? For exam 1, this shaded area represents how many students did better than you. For exam 3, this area here is the area that did better than you for exam 3. Now, when I take an exam, I want fewer people to do better than me. I want fewer people to do better than me. So in fact, in exam 3, this score of 85 represents better performance because not many people did better than you. For exam 1, more people did better than 85 than in exam 3. Okay? Let's think about it a different way, because in order to understand the information in the rest of the semester, you really need to have this concept down pat, sort of. When I say average for a distribution is 75, but we have a standard deviation of 10, well, that means my numbers might look something like this. I mean, I'm just making these numbers up, right? I'm just making these numbers up, okay? But I can imagine something like that giving us a distribution with a mean of 75 and a standard deviation of 10, okay? That's what exam 1 would look like. Exam 3 might look something like this. Everybody with me here? That is, these numbers are going to be much closer together. Average of 75, but a standard deviation of 3 here, because these numbers are really closer together, right? That's what this graph shows. If we look at a bunch of numbers, this is what they might look like. Standard deviation of 10, much more spread out. The numbers might look like this, okay? Just trying to give you a couple of different ways to conceptualize this. If I scored at 85 here, well, I mean, that sort of gets lost in the traffic, right? It's certainly above average, but there's lots of people that are 10 points above the mean. There's lots of people that are 10 points below the mean, okay, and even more. Over here, my score is 85, but all of those scores are really tight around 75. So, an 85 is much more impressive here, where the numbers are closer together, right? This is exam 3, this is exam 1. And 85 doesn't look all that impressive here. 85 is really out there with this group of numbers. Here we see it sort of as a group of numbers. Here we see it graphically. And of course, the concept there is that smaller the standard deviation, the tighter those numbers are around the mean. Larger standard deviation means there's more variability, okay? More deviation, more spread outness if we have a higher sum of squares. So even though you're equally deviant from the mean, 10 points, if the standard deviation is small, that 10-point difference means a lot more than if the standard deviation is large, okay? And that is the concept. And so we're going to go back to our chart now and see if we can't integrate the information that's given to us by the standard deviation, if we can't integrate that into our assessment or evaluation of those numbers, okay? You can rewind the tape and look at this again if you would like. But I'm hoping that this makes a certain amount of sense for you when you think about it. Don't just take it, as some kind of fact to be memorized, but does this make sense to you? Okay, again, if you have questions, you can email me. Let's go back to our graph. Well, before I do that, so what I'm saying is even though you got 85, and even though your deviation score is the same, 10 and 10, I would suggest that we need to think about these two scores differently. We need to evaluate them differently. We need to assess the performance differently. So we're going to do that. We're going to solve that problem using a statistical formula that captures this concept. Again, and I know I sound like a scratched CD or something, but again, the statistical formulas are created to capture the concept. They don't just come out of thin air. So this is a concept that we need to deal with here. Okay. So let's go back. And by the way, I took the two extremes, exam 1 and exam 2, but the same concept applies to exam, for comparing exam 1 to exam 2 or exam 3 to exam 2. It's the same concept. So here we go. Here's exam 1. And we're going to get out of exams as well and talk about, some other research numbers. So you got 85 in each of the exams. We looked at the mean, which was 75 for each of the exams. So, right, so far so good. If you weren't learning this stuff and you weren't getting more sophisticated with how you analyze this, you're like, oh, well, same performance across. And in fact, it is the same in terms of deviations, right? So this is plus 10, plus 10, plus 10. And then we added this little wrinkle here. If the standard deviation was 10, or if it was 5, or if it was 3, would that cause us to evaluate these numbers differently? And the answer is it should. Because this is saying scores are more spread out than this. Scores are really close to 75. Scores are far away from 75. If you're 10 points away from 75, it's going to mean something different. And by the way, just as some good news, I suppose, we have all the information now to make a meaningful assessment, to make a meaningful evaluation of this number. We're going to put this information together, and we're going to do something called a z-score. Okay, a z-score. Now, z-score formula is let me do this. Let me ask another question. If I look at exam 1, how many standard deviations away from the mean? So the mean is 75, your score is 85. How many standard deviations away from the mean are you? Not how many points, but how many standard deviations, right? And most of you, I'm assuming, said, I'm 1 standard deviation away from the mean, right? Because I'm 10 points away from the mean, the standard deviation is 10. So that means I'm 1 standard deviation. Really, we're talking about changing this into a different currency, and that is how many standard deviations, okay? So here's what we're going to do. The z-score is your score minus the mean, so your deviation score, and then divided by standard deviation. So how does your score compare to the mean? That gives you your deviation score. And then how does your deviation score compare to the standard deviation? Okay, I'll write it over here. How do you compare to the mean? So this gives us our deviation score. Then I'm going to compare that to the standard deviation. Here's what we have. It tells you how many standard deviations away from the mean you are. Not how many points. That's this. This tells you how many points away from the mean. This is your deviation score. Z-score tells you how many standard deviations away from the mean you are. How many standard deviations away from the mean you are. Okay? So in this case, we have 85 minus 75 divided by 10. So my z-score is plus 1. Okay, make sure you put your decimals in there. And most of the time, I actually will put a plus sign there instead of leaving it implied, because the z-score, in a way, has 2 pieces of information. The z-score has 2 pieces of information. Positive or negative will tell you whether you're above or below the mean, right? If you have a positive z-score, you're above the mean. If you have a negative z-score, you're below the mean, okay? And then the value tells you how many standard deviations. So for exam 2, what would be my z-score? Now, before you plug in the formula, okay? Please. Let's see if we can do it without the formula first, at least get an idea. The z-score tells you how many standard deviations away from the mean you are. The z-score tells you how many standard deviations away from the mean you are. Because sometimes people will say, the z-score tells you how far away from the mean you are. That's only half true, or it's only half accurate, right? This tells you how many points. So I'm 10 points above the mean. How many standard deviations is that? Well, 10 points. If the standard deviation is 5, then I'm 2 standard deviations. Everybody with me? That's what this formula will do for you. The formula will do that for you. But with these numbers, it should be easier to just sort of eyeball it, right? So if I'm 10 points above the mean and the standard deviation is 5, that means I'm 2 standard deviations. So let's do this. 85 minus 75 divided by 5, right? That's my z-score formula. 10 over 5. My z-score here is 2.00, okay? And then likewise, we have 85 minus 75 divided by 3. And so in this case, we have a z-score of 3.33. And I'm going to put the plus sign there to indicate to the consumer, to indicate to the reader that we're 3.33 standard deviations above the mean, because we could certainly be 3.33 standard deviations below. Anybody know what that score would look like? What that score would look like? If we had a 65 here with a mean of 75 and a standard deviation of 3, we'd have a negative 3.33 z-score. Okay? Look what happens all of a sudden. Look what happens all of a sudden here. Okay? Same score. So people might think, well, I did equally well on each of the exams. Of course, you know that that may or may not be true. What we have to do is compare the person's score to the mean for each exam. Well, in this case, the mean was 75, 75, 75. So the comparison made it look like the person did equally well across each of the exams. Question then is, does this matter? Hopefully, I've convinced you, because it does matter. If we have different standard deviations, then we have to look at this performance differently. Okay? So, we weren't getting any difference with this deviation score. And so what we do is take into consideration the standard deviation. So when I'm assessing performance, when I'm evaluating where a person is at, I'm going to use their deviation from the mean. How do they compare to the average? How do they compare to the average? And then I'm going to put that in terms of how everybody else is deviating from the average. Okay? Z-score. And so in this case, the person who got an 85 with exam 3 did much better than the person with an 85 in exam 1. Okay? I'm only 1 standard deviation above the mean here. I'm more than 3 standard deviations above the mean in this case. Okay? These numbers capture where you're at in a distribution in terms of how far away from the mean you are in standard deviations. Okay? Much more impressive, much more deviant, even though it's the same number of points. If I compare this 10 points to an average deviation of 3, wow, you're really out there. Okay? All right. You can watch this again. You can ask me questions, whatever you want to do. This z-scores are the best way to evaluate people's performance relatively, one compared to another. Now, I can change these numbers. I mean, I hope that you see what I'm doing here, because the numbers are, I'm just changing one variable at a time. I'm trying to isolate that as a teacher to show you what happens. I'm going to really mix things up now. So let's do this. And maybe do something a little bit more realistic. So let's say you had 74 on the first exam, and the average on the first exam was a 70, and the standard deviation was, let's say, 8, okay? And on the second exam, you got an 85, but the rest of the class went up too, because they should, okay? So the average was 81, and the standard deviation was, let's say, 7.5. And the third exam, you got a 90, and the average was at 82, and the standard deviation was, let's say, 10. Okay? This is why I don't use such a realistic example, because it's hard to see what the hell's going on here, okay? And so what I'm going to do is I'm going to get my deviation score, so above the mean here, above the mean. Oh, you're the same number of points above the mean here, and here you're above the mean by 8 points, okay? But I'm going to convert that all to z-scores. I'm going to convert that to z-scores. So I'm going to take my x value, 74, minus the mean, divided by 8. Okay, so here's our z-score. I'm a half a standard deviation above the mean here. This z-score, oh, now I got to do some calculation here. 4 points above the mean, right? Divided by 7.5. So 0.53 here. You did better on the second exam relative to the rest of the class, even though you were still only 4 points. You're making your way up. And here, in this case, 8 over 10 is 0.8. So you did the best on the third exam relative to the other two. Now, I don't want you to get confused, because some people will say, well, I know I did better because of here, okay? These numbers can change, and they can be somewhat misleading. Let's try another one here. Let's try another one, okay? Let's suppose on the first exam you got an 80, and on the second exam you got a 74, and on the third exam you got a 91. Looks like exam 3 you did the best, right? Well, let's say that the average for exam 1 is, let's say, 80. Let's say 80, okay? The average on exam 2 was a 68, and the average on exam 3 was an 85, okay? Standard deviation here, let's say the standard deviation here was 10, and we'll say the standard deviation here was 3.5, and let's say the standard deviation here was 6. Okay? So, our deviation score, 0. Our deviation score here is plus 6. Right? Our deviation score here is plus 6. Not bad. 0 over 10, right? This is my z-score. Well, yep, guess what? If you are on the average, your z-score is going to be 0, because what you're saying is you're 0 standard deviations away from the mean. What's my z-score here? Let's do this. I'm 6 points above the mean, and divide that by 3.5. My z-score here is 1.71. I'm going to put a plus there. I'm above the mean, right? My z-score here, right, I'm 1 standard deviation away from the mean. So in this case, if you take into account the mean, that is, on average, how did people do, and you take into account the standard deviation, your performance was actually the best in exam 2. It was the best in exam 2, second best here. You actually performed the most poorly, I guess. I mean, I wouldn't call that a poor performance, but you didn't do as well on exam 1. There's no way I would know that from looking at the X values. In fact, you were right on average here. You should get a C. Here, and we'll get to this in a little bit, you should probably get an A. That's a very high z-score. At least a B, okay? And here, no more than a B. No more than a B, that's for sure, okay? So that's how this works. We're going to use z-scores to evaluate performance. And I'm going to stop there because I have a visitor